Hi friends, myself Lokesh Chaudhary and today I give seminar on angle sensor. This is the content. Today we discuss about first sensor definition, basic knowledge, and then you discuss about sensor type, which is also the basic. Then we come the point angle sensor, introductions, definitions, and some small little type. And after this development of angle sensor using CMOS chip and MRE sensor, and last one is steady angle sensor. After all of this, we discuss about applications, then conclusion and reference. In CMOS chip and MRE sensor, we also explain constructions, working principle and features. And CMOS chip also we discuss about implemented circuit. So what is sensor? Sensor is a measure device that can be measure the quantity and convert it into a signal which can be read by an observer or by an instrument. And second one is sensor sensitivity. Sensor sensitivity means how much the sensor output change when we change its input. This is the types of sensor types. The many types of sensors found in world are thermal, electrical, electromechanical, chemical, optical, motions, and orientation sensors. In orientation sensor have a scope in which the angle sensor is found. So now, what is angle sensor? Angle sensor is measure the angle of rotating. Any reference point means just measure the angle. And second one, it detects the orientation of the object on which it is placed, and it is also indicate the directions and as well as range of angles. It is used in many applications like automation, and road work and acceleration battery, and then still by technology. In automation, it is used in angle sensor, angle sensor, and steering wheel angle sensor. Steering wheel angle sensor means it removes the mechanical contact of steering wheel pinion to electronic system. In that system, we use the steering wheel angle system. So now we start the first design development of a high precision angle sensor using CMOS chip. CMOS chip. It is a very small and high angle sensor capable of absolute angle detection are required for many applications such as automation, modern industrial and consumer product. Commonly we use a magnetoresistive sensors. But what is the negative point of this type sensor? It has a large cylindrical structure. Therefore, it needs a fine-pitched magnetic scale. Therefore, they cannot detect the absolute angle sensor. But in the method of the single chip CMOS, it can be able to detect the absolute angle sensor. So, what is the magnetoresistive? Let me discuss about magnetoresistive potentiometer. It is nothing for a isolated coil. On which the resistive wire winding is the contact. This is port 1, this is port 2, and this is port 3. And above it a permanent magnet. So we take output from one end depot. This is output, and we give input at 1 and 2. This is magnet 10 volt. We use 10 volt. So when we rotate, a signal is come like that position. Maximum at magnet is this position. So this is a magnetoresistive sensor, and when this the chip can be detect a resolution of 10 bit per rotation, and it can be detection scheme of the system can be categorized and contact type and non-contact type. And this sensor is developed by the Suzuki University Research Institute of Electronics. This sensor is capable to absolute angle of plus minus 0.36 degree. It is enough to say how it is accurate about accuracy. Because it is measured the nearly absolute angle plus minus 0.36, and this sensor also found some trials in this method. Also found trials in ICC205. This is the construction of CMOS angle sensor. In the top, you see a permanent magnet. This is S4 and M4, which is connected to the directly type of rotatory system. Rotatory system, like for example, steady system. When we connect the permanent magnet directly to steady system, it is rotate according to the movement of steady. Then in just perpendicular is sensor chip. It is the maximum length 5 mm and the distance between permanent magnet and chip is nearly 0.5 and 1 mm. This is the block diagram of sensor chip. In sensor chip mainly we use MACFET array, four MACFET array. This is all around the chip. And then they all are connected having a SHE and ADC. ADC means analog to digital converter, and SHE means sample hold amplifier. And the mid is rotation angle calculator, and this circuit is give the output of angle sensor. So this is the real view of chip. This is MACFET array or four directional MACFET array, SHA ADC, and in mid is angle calculator, which is calculate the angle from MACFET array by using method. Now what is MACFET magnetic sensor element? MACFET means magnetic field effect transistor can be manufactured by CMOS. MACFET magnetic sensor element means it contains source and one gate and two drain. And the two drain have a smart distance between them. This is the diagram. Gate, source, two drain. Similarly here, gate, source, two drain. D1 is drain 1 and I1 is current of drain 1, and D2 is drain 2 and I2 is the current of D2. And the final is I signal. I signal is what? I1 minus I2. So in the absence of magnetic field, what we see? In the absence of magnetic field, I1 barabar I2. But when we apply the magnetic field, suddenly a change comes in circuit. The electron movement from source to drain is seen by red, and the blue indicates the electron signal. So by this, a voltage difference develops between D1 and D2, and finally we can take the result. So point is what? How we can measure the angle from this whole arrangement. Let me discuss. These all are four arrays. All array have a SHA and ADC, and let reference angle is this. One thing, the whole system depends on zero line. What is zero line? Zero line is when south pole and north pole contact each other. This point, there is magnetic field is zero. It is called zero line. When the end rotation starts rotate, then the also permanent magnet rotate, as well as the zero line also rotate. And by using the help of chip diagram, we can measure the angle according to the position of zero line. So let me here. This is a reference. Let the position of zero line is this. This is the zero line, and this is the del x, and vertical distance from ground is del y. Now what is what? How we can calculate the theta? We have del x and del y. Theta is calculated directly. Means theta बराबर tan inverse delta y over del x. We have delta y also del x. Delta x is horizontally distance and delta y is vertically distance. By using this method, we can find the angle theta. And the above part is south pole and below part is north pole. See the real figure. Z1 and Z2 are crossing from array. This is 0 line, blue one, and above blue one is south pole and below part is north pole, and all are four arrays. And del y is distance from that to that, and del x from that. So this is the output signal of sensor array using sensors number with sensor output. Z1 and Z2 I already told that Z1 and Z2 is crossing point of array due to 0 line. So after we calculating the angle, how we can calculate angle? We use a sensor data line to KB and give the four output 81, 82, 83 and 84. All are four types array. So directly pass through 0 point detector. It can be used by method least means for finding. We can able to find the 0% point detection. And the output of the whole calculator in 10 minutes. See the output is 10 minutes. And it also having a circuit communication circuit which is are used to communicate outside the world. Means how if we transfer the data in another world. And this is the detection of 0 line. This is stresses curve. Above part is north pole and this is south pole. And the point where both are meet, see there, it is 0 line. Means at that point, now magnetic field is 0. And we can easily find the value of y using theta over del y over del x. Now problem is what? In this circuit, the CMOS chip is made by silicon. Therefore, the sensitivity of the whole circuit of magnetic is very low. So, how we increase the sensitivity with magnetic? We can use a native magnet. Native magnet means what? It is directly connected to CMOS and it has two advantages. First one is what? Compared to P1 region, the impurity concentration on the P substrate is lower. P substrate is lower means what? This is going to lead to high electron mobility with the native magnet. Casing the magnet chip sensitivity is increased. Second point is what? P1 region formed through a ion implantations. According, it is the sensitivity and whole characteristic of circuit and also device is depend on the ion implantation. It is vary according to the ion implantation. But in native magnet, what is the big advantage? It is not affected by the any types of ion implantation. The next one is comparison between native and normal. See the normal, it is non-charged with sensitivity nearly accurate and also the current when we increase the current, no difference in sensitivity, it's just constant measurement. But in native magnet, see the black line, it is having at that point very high and also decrease with increase the current, but it has high end sensitivity than normal magnet. So conclusion features. It is an angle calculator which is work on principle of magnetic field distribution. It is not affected by the non-linearity, and the main point is what is reduce the noise because we use four types